So in section 6.4, we're going to talk about what a definite integral is. We'll talk about how to use a calculator to integrate or to find the values of definite integrals. And we're going to talk about the fundamental theorem of calculus. So a definite integral is written with upper and lower bounds. And what I mean by that is you look at this a and b, that is the lower, a is what we consider to be the lower bound, and b is what we consider to be the upper bound. A definite integral gives you the signed area under a curve, so between a curve and the x-axis. A is usually the left boundary, and b is usually the right boundary. And then the area is between the curve and the x-axis. If it's above the x-axis, then we consider it to be a positive number, a positive area. If it's below the x-axis, then we consider it to be negative. Unlike when we did the previous problems we've done when we've integrated, they are what we call indefinite integrals. When you do that, you end up with another function. When we do find the definite integral, it actually comes out to be a numeric value because it has to be an area. And this will make a little more sense. We'll find a couple of these in the calculator, and I'll show you a graph of what they look like, and hopefully that will make more sense. Okay, so what we use in class, right, is the 84. That's what I'm going to use in here. But an TI-84 or most other graphing calculators will find the value of a definite integral. And you can do it one of two ways. You can use the calculate menu, or you can go on the math menu on the main screen and do it that way. The nice thing about the calculate menu is it does give you a graphical representation of what you're finding. So let's do a couple with using the calculate menu, and then we'll go back and we will use the math menu. So let's start out, go into the y equals. Now I want to find the definite integral of the lower bound's -3 to the upper bound 1 of x cubed minus 6x. So the way we do that is first start out in the y equals. I'm going to put in the x cubed. Whoops. The x cubed minus 6x. I'm going to graph that. I'm just going to switch it back to a standard window to make sure that I don't have some kind of crazy settings in our window. All right, it ends up looking like that. Now we want to find the definite integral. That's what I'm really finding is I'm starting at -3, which is right there. And I want to find the area between the curve and the x-axis from there over to +1. So to do that, we go into the calculate menu, which is right up here. So second calc. And we go down to, right, there's my integral right there, the integral of f of x dx. Hit enter, and it's going to ask first for the lower bound. Okay, so we're going to put in -3 for the lower bound. Hit enter. You'll see it draw that line right there. That's where it's going to start looking. And then upper bound, put in +1, and it should trace it there for us. Okay, so if you look at this, right, it tells us down here, this is the integral of f of x d of x from -3 to 1, and it comes out to be 4. So what it's doing is the area below the x-axis, that sliver right there, and this portion right over here counts as negatives. This part here, because it's above the x-axis, counts as positives. So if I take this negative plus that positive plus that negative and add it all up, it comes out to be a +4. That means that there was more area above the x-axis than there was below, right? Because it came out to be a positive. So that's my answer. And that's what we're talking about is when you do a definite integral, you end up with a numeric answer. So that integral is equal to a +4. But again, what that represents is the area under the curve, or the signed area under the curve. And just remember the part below, here and here, counts as negative. The part up there counts as positive. Okay, let's try it again. Let's do this next problem. Notice it's the same function. It's still x cubed minus 6x, but now we're going from -square root of 6 to +square root of 6. So let's try that. So go back into the calculate menu. Actually, you know what? First, if you would, go back into y equals. I want to clear that graph. If you go on here and hit enter on the equal sign, that turns the graph off, and graph it again, and now it should just be blank. And now go back in and turn it back on. If you don't do that, then it will show it will show the area that we shaded previously will still be on there, and I just want to clear that off. Okay, now that I'm back just to that graph, I'm going to go into calculate, go down to the integral, and we're going to go from the lower bound is negative square root of 6 and we're going to go to positive square root of 6. All right, there's my lower bound, there's my upper bound. Okay, when you do that, if you look at it, because this graph is symmetric, what you'll end up seeing is that positive area is exactly the same as that area below the x-axis, which is negative. So when I add them together, it comes out to be 0. Now that only works in this case because the graph is symmetric. That won't be the case for every function, but this function, when I say symmetric, it's symmetric about the origin, right? So the areas come out to, the positive and negative area comes out to be equal, so it comes out to be 0 altogether. You guys try this last one. Try number 3, find your answer, then we'll come back together and we'll do it together. So pause it and do that and then come back with me. Just in case you've forgotten, when to put in an absolute value, you hit the math key and then you go over to numbers, and the absolute value is that very first option. So the absolute value of x to the third. Now we know what this is going to do to the graph because we know about transformations. It's the same graph as before, but it's going to take everything that was below the x-axis and reflect it up. So it ends up looking like that. We're trying to find the area from -5 to 5. So second calc, go down to the integral. Lower bound is -5, upper bound is +5. Okay, ends up looking like that. That's the area under the curve, so our answer is 198.501. Okay, so that's using the grapher and the calculate menu to find the answer. The other option is we can also use the math menu in the main screen. So let's do that. Let's go into the main screen and use the math menu, and we'll do the same problem as we just did. So let's X out of here, hit the math menu, which is right here, and I scroll all the way down. Right, there's our n derived. That's our derivative. This is our integral. Right, the INT stands for integral. Click enter on that. Put in your lower bound. Put in your upper bound. Right here we put in our function. Don't forget the absolute values. So I have to go back in the math menu over to numbers and select the absolute values of x to the third. Minus 6x. And then we were using x as our variable, so x would go over there. Hit enter. Let's compare this answer to what we just got on that example number 3. So it's thinking. It does take these sometimes just a moment to find it. So I ended up, this one gave me the answer of 198 point, we go 3 decimal places, right? 500. All right, so if we compare those two answers, for my first one I got, when I did it with the calculate menu, I got 198.501. For the math menu, I got 198.500. They're really close, but they're not the same thing. So this is really important. On the AP test, you want to use the math menu. The math menu is the most accurate one. So even though they're close, if you want to get full credit, you've got to use the math menu. Sometimes they're so close that you might end up getting the same value, but sometimes you won't. So in general, if they ask you to do a definite integral, the calculate menu with the grapher is really nice because you get a visual representation of it. But the math menu is the most accurate one, and that's the one they'll expect you to use. So just one more time to make sure we're clear on that. Even though you have the two options for finding a definite integral, we're going to use the math menu when we do that. I'm going to stop this video here, and I'm going to do the rest of this on my smartboard. And then I'll just have a second half that you can go through. But this is the first part. Hopefully that explains what a definite integral is, along with also how to find definite integrals using the calculator.